Class 9, Chapter 8, Quadrilaterals, Module 2. Objectives. In this module, you will learn about the midpoint theorem. Listen carefully, students. The midpoint theorem. The theorem statement is important. The proof is not important. So listen that. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. That is, listen carefully. In this figure, D is the midpoint of the side AB and E is the midpoint of the side AC. So using this midpoint theorem, the line segment joining the midpoints of two sides of the triangle. So the line segment is which one here? DE is parallel to the third side. So that DE is parallel to the side BC. And now listen carefully. If the line segment adjoins the midpoints of any of the sides of the triangle, then the line segment is said to be parallel to all the remaining sides. And it measures about half of the remaining side. So listen carefully. Here we mark the midpoints of the side AB and also AC. Now, which one is the line segment? DE. So DE is parallel to BC. Now when we join the midpoints of the sides AB and also BC, then that line segment is parallel to which side? AC. Same as when we joined the midpoints of the other two sides BC and also AC, the line segment is parallel to the side AB and it is half of that side. So that here in this case DE is half of which one? BC. The line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. So listen carefully, it's converse. The line drawn through the midpoint of one side of a triangle parallel to another side is bisect the third side. Okay, now listen carefully. The problems. So many problems are there. Now only 7 problems are there in this exercise. Okay, so listen. ABCD is a quadrilateral in which P, Q, R and S are midpoints of the line AB, BC, CD and DA. AC is the diagonal. Show that. First one, SR parallel to AC and SR is equal to half of AC. Second, PQ is equal to SR. Third one, PQRS is a parallelogram. Now listen. First one, SR parallel to AC and SR is equal to half of AC. For that, first given ABCD is a quadrilateral where P, Q, R and S are the midpoints of the sides AB, BC, CD and DA respectively. We need to prove SR parallel to AC and SR is equal to half of AC. For the proof, in triangle ADC, consider the triangle ADC. S and R are the midpoints of the side AD and CD respectively. Therefore, SR parallel to AC and SR is half of that side AC. That is, the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. Now second one, what? PQ is equal to SR. Same as in the previous part, we proved SR parallel to what? AC. And SR is equal to half of AC. Put equation number 1. Now in triangle ABC, the second part. In triangle ABC, P and Q are the midpoints of the side AB and BC respectively. So PQ parallel to AC and PQ is half of AC. That is the reason what line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. Now from that first one and second one, PQ is equal to SR and PQ is parallel to SR. So listen carefully in the first one, what SR parallel to AC and SR is half of AC. Second one, what PQ parallel to AC and PQ is equal to half of AC. From that too, we can write what PQ is equal to SR and PQ is parallel to SR. Hence the proof. Now next one, what PQRS is a parallelogram. So in this previous part, we prove what PQ is equal to SR. Also we proved what PQ parallel to AC and SR parallel to AC. So what PQ is parallel to SR. Now in triangle PQRS, one pair of opposite sides of it is parallel and equal. So what we can write, PQRS is a parallelogram. We know that what one side opposite side of a parallelogram is parallel and equal, then that quadrilateral become what parallelogram. Now listen carefully. Next question. ABCD is a rhombus and PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. So listen carefully here. Given what ABCD is a rhombus. Rhombus means what? All sides are equal. Now we need to show what that quadrilateral PQR is a rectangle. Okay. So listen for that first one. Given condition ABCD is a rhombus where PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. We need to prove PQRS is a rectangle. For that, join A and C. Now, the proof. A rectangle is a parallelogram with one angle 90 degree. So, what we want to do first? First, we want to prove PQRS is a parallelogram and then we need to prove what? One angle 90 degree. So then become what? A rectangle. Now the first part, listen. In triangle ABC, P is the midpoint of AB and Q is the midpoint of BC. Now listen. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. So PQ parallel to AC and PQ is half of AC. Same as that in triangle ADC, what? RS is parallel to AC. RS is half of AC. Now listen carefully to equations 1 and 2. From that 1 and 2 we can write PQ parallel to RS and PQ is equal to RS. Now in PQRS, one pair of opposite sides is parallel and equal. Hence PQRS is a parallelogram. Now we had to prove what? PQRS is a rectangle. For that, listen. Since AB is equal to BC, sides of rhombus are equal. Okay. Now consider the half of it. Half of AB equal to half of BC. So PB, half of AB what? PB is equal to half of BC what? BQ. Since what? P is the midpoint of AB and Q is the midpoint of BC. Now in triangle BPQ, PB is equal to BQ. Therefore, angle 1 is equal to what? Angle 2. Angles opposite to equal sides are what? Equal. Put equation number 3 there. Now in triangle APS and triangle CQR, first one condition, AP is equal to CQ. Why it is? Plus an AB equal to BC. Now which implies what? Half of AB is equal to half of BC. So half of AB is which one? AP and half of BC is what? CQ. Same as AS is equal to CR. Why? AD equal to CD implies half of AD equal to half of CD. Implies what? AS is equal to CR. Now next one, what? PS is equal to QR. That is, opposite sides of the parallelogram are equal. So the two triangles APS congruence to triangle CQR using SSS congruence rule. Now we can write angle 3 is equal to angle 4 using what? CPCT. Put equation number 4. Now AB is a line. So angle 3 plus angle SPQ plus angle 1 equal to 180 degree using linear pair. Put equation number 5. Similarly for the line BC, angle 2 plus angle PQR plus angle 4 is equal to 180 degree, linear pair. Now angle 1 plus angle PQR plus angle 3 is equal to what? 180 degree. From that, equation number 3 and equation number 4. Now put that equation number 6. From 5 and 6, angle 1 plus angle SPQ plus angle 3 equal to angle 1 plus angle PQR plus angle 3. Now cancel angle 1 both sides, angle 3 both sides. So remaining what? Angle SPQ is equal to angle PQR. Put equation number 7. Now PS parallel to QR. Opposite sides of the parallelogram are parallel. And PQ is the transversal. So angle SPQ plus angle PQR is 180 degree. Reason what? Interior angles on the same side of the transversal are supplementary. So angle SPQ plus angle SPQY, angle SPQ is same as angle PQR in equation number 7. So angle SPQ plus angle SPQ is 180. That is twice of angle SPQ is equal to 180. So angle SPQ is equal to 180 by 2 is equal to 90 degree. So PQRS is a parallelogram with one angle 90 degree. Then PQRS is a rectangle. Hence proved. Now the next one, ABCD is a rectangle and P, Q, R and S are the midpoints of the side AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. Now given ABCD is a rectangle where P, Q, R and S are midpoints of the side AB, BC, CD and DA respectively. We need to prove what? PQRS is a rhombus. For that, join A and C. Now for the proof, a rhombus is a parallelogram with all sides equal. So first we need to prove that PQRS is a parallelogram and then prove all sides equal. Okay, now listen carefully. In this figure, triangle ABC, P is the midpoint of side AB and Q is the midpoint of side BC. So same reason, we can write PQ parallel to AC and PQ is half of AC. Same as RS parallel to AC and RS is half of AC. Same type. From that to equation 1 and 2, we can write PQ parallel to RS and PQ equal to RS. Now in PQRS, one pair of opposite side is parallel and equal. So PQRS is a parallelogram. First part over. Now we need to prove what all sides equal. Now in triangle APS and BPQ, AP is equal to BP. Why? P is the midpoint of AB. Now angle PAS is equal to angle PBQ. All angles of rectangle are what? 90 degree. Now AS is equal to BQ. Same type of reason. What? AD is equal to BC. Half of AD is equal to half of BC, which implies what? AS is equal to BQ. Therefore, triangle AP is congruent to triangle BPQ using SAS congruence rule. Therefore, we can write PS is equal to PQ using CPCT. Now, but PS is equal to RQ and PQ is equal to RS. Opposite sides of the parallelogram are equal. Therefore, PQ is equal to RS is equal to PS is equal to RQ. Now listen, thus we prove what all sides are equal. Thus PQRS is a parallelogram with all sides equal. So PQRS is a rhombus. Okay. Now listen carefully the next one. ABCD is a trapezium in which AB parallel to DC. BD is the diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB, intersecting BC at F. Show that F is the midpoint of BC. We need to show what F is the midpoint of the side BC. Now given ABCD is a trapezium where AB parallel to DC. A is the midpoint of the side AD, that is AE is equal to DE, and EF parallel to AB. Given condition EF is parallel to AB. We need to prove F is the midpoint of BC, that is BF is equal to what? CF. Now for the proof, let EF intersecting BD at G. In triangle ABD, E is the midpoint of the side AD and EG parallel to AB. As EF parallel to AB, parts of the parallel lines are parallel. Using that reason, what? EG parallel to AB. Now therefore G will be the midpoint of DB. That is a line drawn through the midpoint of one side of a triangle parallel to another side and bisect the third side. So G will be the midpoint of DB. Given EF is parallel to AB. AB is parallel to CD. So EF is parallel to which side? CD also. Now in triangle BCD, G is the midpoint of side BD and GF parallel to CD. So as EF parallel to CD, parts of the parallel lines are parallel. So using that we can write in this way. Therefore F is the midpoint of BC. That is a line drawn through the midpoint of one side of the triangle parallel to another side, bisect the third side. Now thus we prove F is the midpoint of what? BC. Now fifth question. In a parallelogram ABCD, E and F are the midpoints of the side AB and CD respectively. Show that the line segment AF and EC trisect the diagonal BD. Now given ABCD is a parallelogram where E and F are the midpoints of the side AB and CD respectively. We need to prove AF and EC trisect BD. That is BQ is equal to QP is equal to DP. For the proof, ABCD is a parallelogram. Therefore, AB parallel to CD. Opposite sides of the parallelogram are parallel. Implies AE parallel to CF. Parts of parallel lines are parallel. And AB is equal to CD. Opposite sides of the parallelogram are equal. Now half of AB is equal to what? Half of CD. Therefore AE is equal to CF. Given what? F is the midpoint of CD and E is the midpoint of AB. Okay. Now in AECF, AE parallel to CF and AE is equal to CF. One pair of opposite sides is equal and parallel, so AECF is a parallelogram. Now, which implies what? AF is parallel to CE. Opposite sides of the parallelogram are parallel. Therefore, PF parallel to CQ and AP parallel to EQ. So, parts of parallel lines are parallel. Now, listen, in triangle DQC, F is the midpoint of DC, so PF is parallel to CQ. Therefore, P is the midpoint of DQ. That is, here listen, the line drawn through the midpoints of one side of a triangle parallel to another side and bisect the third side. So, listen carefully. Using that P, write that way. Therefore, here P is the midpoint of DQ. Implies PQ is equal to DP. Put equation number 1. Same as E is the midpoint of AB and AP parallel to EQ. So therefore we can write Q is the midpoint of BP, implies PQ is equal to QB. Put equation number 2. From that two equations 1 and 2, DP is equal to PQ is equal to BQ. So it is trisected, equally divided. That is DP is equal to PQ is equal to what? BQ. Hence the proof. Now show that the line segment joining the midpoints of the opposite sides of a quadrilateral bisect each other. Now listen the solution. Given ABCD is a quadrilateral, PQR and S are the midpoints of the side AB, BC, CD and DA respectively. We need to prove PR and SQ bisect each other. That is, OP equal to OR and OQ is equal to OS. We need to prove. For that construction, join A and C. Now the proof, listen carefully. In triangle ADC, S is the midpoint of AD and R is the midpoint of DC. Now using line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. So SR is parallel to AC and SR is a half of AC. Put equation number 1. Same as PQ is parallel to AC, PQ is half of AC. From that first one and second one equations, we can write PQ is equal to SR and PQ is parallel to SR. So in PQRS, one pair of opposite sides is parallel and equal, hence PQRS is a parallelogram. PQ and SQ are diagonals of the parallelogram PQRS, so OP is equal to OR and OQ is equal to OS. Diagonals of the parallelogram bisect each other, hence the proof. Now the last question. Listen, only 7 questions in this exercise. Now some example question also. Okay. ABC is a triangle right angled at C. A line through the midpoint M of the hypotenuse AB and parallel to BC intersect AC at D. Show that D is the midpoint of AC. Second, MD perpendicular to AC. Third one, CM is equal to MA is half of AB. Now the first one, D is the midpoint of AC. For that given, triangle ABC is right angled triangle. Right angled at what? C. So angle C 90 degree. M is the midpoint of AB and MD parallel to what? The side BC. We need to prove D is the midpoint of AC. That is, we need to prove what? AD is equal to CD. Now, in triangle ABC, M is the midpoint of AB and MD parallel to BC. Therefore, D is the midpoint of AC. That is a line drawn through midpoint of one side of a triangle parallel to another side bisect the third side, converse of that. Now the second one, MD perpendicular to AC. As MD parallel to BC, and AC is the transversal. Angle MDC plus angle BCD equal to 180. Interior angles on the same side of the transversal are supplementary. So angle MDC plus 90 degrees equal to 180. Angle MDC is equal to 90 degree. Therefore, MD perpendicular to AC. Hence the proof. Okay. Clear, students? Now listen carefully. The last one, CM is equal to MA is half of AB. For that, joint MC. Now in triangle AMD and CMD, AD is equal to CD. Proved in that first part that D is the midpoint of AC. Now angle ADM is equal to angle CDM, both 90 degree, as MD perpendicular to AC, proved in the last part. DM is equal to DM, common side. So that two triangles are congruent using SAS congruence rule. Therefore, AM is equal to CM using CP CT. Put equation number 1. However, AM is equal to half of AB, given that AM is the midpoint of AB. Put equation number 2. Now from 1 and 2, CM is equal to AM is equal to half of AB. Okay, clear, students? Okay, thank you.